On February 15th, 1976, the doors open at a hangar at the Boeing Downey plant in California, and the public, which are gathered to watch, and the press, see rolling out of that hangar a remarkable new kind of spacecraft, the first with wings. Rockets will launch it into orbit, but it lands like a plane. The new orbiter is called the Space Shuttle. And one of the people who was in the crowd was astronaut Bob Crippen. He said that the first time he saw the shuttle riding on the back of that 747, he said he thought they had screwed up bad. This is never going to work. NASA is reinventing itself. The new orbiter is designed for more practical missions. We can't afford to spend $2.4 billion every single time we want to launch man into space if we keep the Saturn production lines open. So we start to build this safe, reliable, on time, and most importantly, cheap, reusable spacecraft. And the mission of a shuttle is that we would retrieve packages in that we could accomplish repair on, we could launch satellites, we could carry up the space hab modules, and eventually use it to build a space station. And it was this amazing thing that we had, that we thought to ourselves, let's go build a space plane that could take off on rockets and land like a conventional airplane on a runway. And the remarkable thing about the space shuttle is that, not bringing into question the fantastic nature of spacecraft standing up to the harsh environments of space just once, the shuttle has to do it over and over and over again for up to 100 missions per shuttle. Temperatures of 9,000 degrees as these things come into Earth's atmosphere. These will generate enough energy and heat that if it were transferred into electrical energy could light up the city of Los Angeles for a minute and a half. So we need such a durable thermal protection system, heat shield, for the shuttle as could be reused again and again and again. So we decide that we're going to use this substance called silica, which is an extremely strong, extremely poor heat conductor, which makes it perfect for heat shields, because you can spend 10 minutes in a oven at 4,000 degrees and within a few seconds it's cool enough to touch and pick up. The only problem with silica is that it's extremely brittle. It breaks like the bottom of a riverbed after it's dried up. It cracks. So the way we come over that problem is by pre-cracking this silica heat shield into 31,000 1-inch square tiles, which blanket the whole entire orbiter. And these tiles are what our thermal protection system primarily consists of aboard the shuttle. They're about the consistency of styrofoam, and they're glued on. Twin solid rocket boosters will provide 44 million horsepower to launch the shuttle into space, and 3 main engines will provide sustaining ability to take her up into orbit. And these engines have to be compact, reliable, and able to be used over and over again. And John Young said that when they were testing out these rockets, he said that every time they turned around to discuss it, one of the engines would blow up and catch fire. He said he didn't think it would be so tough to get there from where they're at, but that was a pretty tough road. So it was an incredibly complicated endeavour just to get one of these shuttle main engines ready to fire, much less getting 3 of them together to deliver this enormous amount of thrust, to get 7 astronauts and enormous amounts of payload as we could into space. The shuttle could basically carry as much payload as could fit inside its big cargo bay. Because that's what we wanted to do in the shuttle. Not to explore space, but to exploit it. The shuttle is what drove our satellite revolution of the 1980s and 90s and allowed things like mobile phones and the internet, email, to be able to be used for the first time. So this was our idea. We want to be able to make money out of space, and that's what the space shuttle allowed us to do. We only have a finite amount of money from the government to develop the space shuttle, so we consult the United States Air Force, who agree to give funding and expertise to the space shuttle development in return for giving the shuttle the ability to carry military satellites into orbit for classified missions. And 7 classified missions were flown for the Defense Department as part of the shuttle program. So this gave us the development to go ahead and build Enterprise, the first shuttle. And the reason we called it Enterprise, it was originally called Constitution, was that fans of a particular long-cancelled science fiction series led a successful write-in campaign to have it named after the Starship Enterprise from Star Trek. And indeed, when we rolled out the shuttle at Downey, the cast from Star Trek were all there for publicity to get their photograph taken with the new orbiter. So that this was this amazing new thing, and we started to build the second orbiter, Columbia, to be the first to fly in space.